I'll be presenting our work understanding users' perception towards automated personality detection with group-specific behavior data. This work is done by Seyoung Kim, who is the presenter, Artit Thakur, and Juho Kim. Due to various importance of personality in collocated group space, affecting from how they work to how they interact with each other, it has now become common to conduct personality assessment of members in the collocated group. There exist diverse kinds of personality tests with their advantages and disadvantages. Most widely known personality test is self-assessment, such as MBTI. Even though it is easy to apply, it requires users to spare time to take the questionnaires each time they take the test, while personality changes over time. On the other hand, automatic personality assessment tries to overcome these issues by predicting the user's personality by analyzing their reactivity when assigned a specific simple task or everyday behavior data. However, assessing personality by giving a specific simple task, such as analyzing reactivity when giving a presentation, is one-time measurements and cannot capture personality changes over time. On the other hand, measuring personality by analyzing logs of sensors or logging technologies, such as social media profiles or wearable device logs, have potential to measure personality continuously without direct involvement of users. Despite this potential, applying these systems in practice may face resistance from users due to the use of potentially privacy-intrusive behavior data. Therefore, careful understanding of users' perception towards behavior tracking for automatic personality assessment is needed to measure personality continuously without giving burden to users. Despite these needs, previous studies have focused on understanding users' perception only towards the detected personality result. However, not only focusing on the detected result, there exist various dimensions to consider affecting users' perception when designing an automatic personality assessment systems. Therefore, a deeper understanding of users' perception towards automatic personality assessment systems across various dimensions is needed. To this end, we try to understand users' perception towards personality detecting systems with everyday behavior data in a collocated group, which we refer to as APA hereinafter. For this, we took a mixed methods approach using a survey and interviews with the participants who used our research probe to understand users' perception comprehensively. Even though we could get opinions from a large number of diverse populations from survey, respondents have to answer the survey questions based on their thoughts without actual experience. So by interviewing those who used our research probe, we also gathered opinions from those who actually experienced an APA system. For the survey, our goal was to understand respondents' acceptability of sharing their behavior data in terms of privacy. As I said, since survey respondents often have to answer questions based on their presumption rather than actual experience, we focused on questions that could be relatively easily answered based on presumption. In addition, to know which data streams to collect when designing an APA system, by understanding how users' behaviors differ among the data streams, we also investigated potential differences between online and offline group behaviors. We recruited 89 full-time employees working in a collocated group environment for the survey. From the survey, we were able to find four things. First, we found that there exists a difference between online and offline group social behavior patterns, both in terms of frequency and time spent on them. For sharing data, respondents overall did not find it acceptable to share any behavior data with their company or organization. However, sharing only group-specific data, meaning that data only captures behaviors displayed within the group, with an option to exclude specific data entries, can increase acceptability of sharing data. We also found that their acceptability of sharing data differs significantly across the data streams. They were more acceptable sharing group-specific online chat logs or offline location logs than audio or video recordings, or even audio features. We also found that reducing the scope of data collection could increase acceptability in sharing data. For example, even though respondents were relatively not acceptable with sharing all messages, respondents were more acceptable when they had to share messages with a reduced scope, excluding direct messages in Slack. To further gain insights into user perception based on the actual experience of using APA systems, we built a research probe based on the survey findings. Our research probe consists of two phases, which are data collection and model building to detect personality. Our research probe uses both online and offline group-specific behaviors, which are online chat logs, online web or app usage logs, offline position logs, and offline movement logs. We also lowered privacy concerns of participants by applying the survey results and applied different levels of obtrusiveness for different data streams, considering the possible privacy concerns. For example, while for online chat logs, we only informed participants about the data collection before the data collection began, as survey research indicated online chat logs were relatively okay to share. But for web app logs, we gave frequent reminders throughout the data collection, as survey research indicated that it could be privacy-wise intrusive. This was done to better understand appropriate level of obtrusiveness of an APA system. We recruited 4 different research groups in a university in Korea to use our research probe, which includes data collection using Slack, rescue time, BLE beacons, and smartwatches for 3 weeks. After the data collection, we extracted 41 behavior features, such as initiating a conversation in online chat and staying in one's own seat. Then we built an APA model to determine users' Big 5 personality. Big 5 personality is personality trait theory that describes one's personality into 5 different dimensions. We classified each personality dimension into 3 levels, low, medium, and high, as minor difference within each personality dimension wouldn't mean much difference. We selected the best model for each personality among a range of classification algorithms, such as linear support vector classifier and random forest. To understand users' perspective towards our research probe, we recruited 9 out of 32 participants who participated in the study for a post-interview. During the interview, we showed them their collected data and asked their opinions regarding sharing the data for automatic personality assessment in the group. Moreover, we asked their opinions on sharing their personality result driven from their behavior data while showing them the system prediction and their self-assessed result. For analyzing the interview data, we conducted thematic analysis. As a result of thematic analysis, we were able to identify 4 emerging themes: privacy, behavior change, trust in result, and benefits. For privacy, some participants expressed concerns about sharing their data or personality prediction result due to potential misuse of the data or intuitive concerns or without a clear reason, and clear privacy concerns towards the current scope or purpose of data collection. Even though we provided a high-level summary of data collection scope, it still left a room for imagination on what to be collected. So in order to reduce the first type of privacy concern, providing raw data with an appropriate explanation could be necessary. To alleviate second type of privacy concern, careful design of API system is needed, especially in terms of what to collect and how to collect behavior data. For behavior change, participants who reported behavior change due to the system said they changed their web app usage but not other behaviors, which were deployed with high intended level of obtrusiveness, where we not only informed about the data collection before it began, but also provided real-time and weekly report on collected data. Those who reported so pointed out privacy concerns arising from the observer effect, meaning the awareness of being observed. P33 said, "There was a feeling that someone was watching me and my behavior seems to change because of that." Participants also pointed out self-monitoring as a reason behind their behavior change. P29 said, "I could track my web app usage, so I wasted time less than usual." Participants reported no sign of recovering their natural behaviors when the reason behind their behavior change is privacy related. But on the other hand, for those who reported behavior change due to self-monitoring, their behavior was likely to return to their natural state after a while as they got accustomed to the system. For trust, participants reported that their trust in results was affected by data-driven aspect of the system, self-perception of their own personality, and ambiguity around how the system works. Especially for data-driven aspect of the system, it both had positive and negative effect on participants' trust towards result. In fact, for some participants, even though they were provided with predicted personality, which was different from their self-assessed personality, they showed trust towards the system-driven personality. On the other hand, some participants showed disbelief due to the limited data collection scope when presented with the result. Finally, for benefits, several participants mentioned the possible benefits of the system. They pointed out that utilizing data for other purposes, such as reflecting on their own productivity and knowing their own or others' personality to have better interaction with other group members, could be useful. They also pointed out benefits of using API system, utilizing behavior data over other personality measurements, saying that it was more convenient as they don't have to think to answer the personality test. Based on the survey and interview results, we came up with design implications for user-centered design of an API system. For a user-centered design of API, it is important to consider users' perception regarding privacy, behavior change, trust, and benefit, along with the system accuracy. Therefore, even though collecting data exhaustively can increase the system accuracy, it is important to consider the gain in system accuracy relative to the cost in users' perception for the system to be actually used in the wild. For a more detailed explanation on our study, please refer to our paper. Thank you.